This video is for the linear factors of quadratic functions notes. So what we're going to do is we're going to find the linear factors of a quadratic from a table and using a graph. So given the polynomial function x squared plus x minus 12, determine the linear factors of f of x using a table. So we could plug all these values into our function, or we can use the graph feature. So we've got x squared plus x minus 12, and then we can do Control T and pull up this table and write our data down from here. So we've got 8, 0, negative 6, negative 10, negative 12, and then 0 is negative 12, negative 10, negative 6, 0, and 8. All right, so what I'm looking for, we're looking for the x-intercept. So we're looking for where the output is 0. Okay, so those two outputs are x equals negative 4 and x equals 3. If I write those as factors, it would be x plus 4 and x minus 3. And if I take those two factors and I multiply them together, so I'm going to use FOIL. X times x is x squared. X times negative 3 is negative 3x. 4 times x is positive 4x. 4 times negative 3 is a negative 12. Combine like terms, x squared plus x minus 12. I can check to make sure that I pulled the right factors. Okay? So I can do it from a table, find the x-intercepts, write the factors. I can also do it with a graph. So if I use a graph, I'm going to do something really similar here. So in the graph on my calculator, I'm going to graph this function, 2x squared minus 7x minus 15. And I'm going to pull up the table. And then we're going to do values that we know. Okay? So we go all the way to negative 3. So when x is negative 3, y is 24. Well, that doesn't work. Okay, when x is negative 2, y is 7. So I can do that one. Negative 2, 7. There's a dot there. Negative 1 and negative 6. 0 and negative 15. 1 and negative 20. 2 and negative 21. And then 3 and negative 18. 4 and negative 11. 5 and 0. So there's one of my x-intercepts. And then 6 and 15. That one's not on the graph. So I can draw out this parabola, connecting my dots here. And so I have one of my factors there. So to get the other factor, since it's not nice and pretty, I can do menu, 6, and 1, and kind of capture this 0, and it will tell me what that factor is. So my factors here, negative 1.5 as a fraction is negative 3 over 2. You do need that in fraction form. To change a fraction, go to this one. So if I do negative 3 over 2, if I put a decimal on the, or do it this way, negative 1.5, and I can do menu 2, and it will change it into a fraction form. But you do need it in fraction form. And then x equals 5 was the other one. Okay, so here are my two factors. So x plus 3 over 2 and x minus 5. But we don't like it like this. So we can use kind of like the slip and slide method. It's the end part of it. I can slip this 2 to the front and change this to 2x plus 3 times x minus 5. We don't like fractions here, but we don't like decimals there either. So that's why I say you need it in fraction form so you can slip that denominator to become the coefficient. So 2x plus 3 times x minus 5. So we can FOIL that. 2x times x is 2x squared. 2x times negative 5 is negative 10x. 3 times x is 3x. And 3 times negative 5 is negative 15. Combine like terms. Negative 10 and 3x is negative 7x. And just check to see that we ended where we started.